Hey you guys, so check it out. I'm gonna try to clear up some misconceptions when trying to graph trigonometric functions. Um, now, and the biggest problem is trying understanding exactly how they are uh, interpreted, or they are kind of translated from the unit circle to their own graphs, and I see that's where students have the most difficulties. So let me get into it. Oh, and another thing, I'm trying to clear up misconceptions. Like, a lot of students didn't know why, or couldn't understand why x and y corresponds to sine theta, or cosine theta, sine theta, respectively, when given points on the unit circle. So I want to also put that into clarity. Okay, so check it out. If we say give, a specific angle, and I want to do in radians. Remember, radians are degrees, and we're thinking radians right now. Um, Remember, in higher levels of calc and physics and everything, you're always using radians. Okay, so if we rotate this, or if we commit or execute an angle of 30 degrees or pi over 6 radians, we know we have that point right here on the unit circle, and by convention we know that it is what? For some reason, let me point. Okay, x is what? So we know it's root 3 over 2, right? And I know a lot of the students are given this handouts just to memorize these things, but I want to go a little bit deeper and put in perspective, and I think we did that in the last video. Now, this is also a radius of 1, or if we look at it in terms of a triangle, and I put a little an arbitrary side right there, then we can have a right angle, right? So this is now a triangle, and we can see it in that perspective. We know that this side that we just arbitrarily added, right, is actually 1/2. And then this side, which corresponds to the x-axis, so you know this is going in the y direction. This is the y-axis right here, right? And x. And then, so anything that lies on the x-axis is root 3 over 2, right? Okay, so but how does that correspond to or relate to sine, cosine? Well, when given the trigonometric functions, you're given SOHCAHTOA. What is it? TOA, right? Again, another conventional tool to be used and utilized, helps you memorize these things. So if we take sine of theta, right? And what's our theta? In this case, it's pi over 6, right? Sine of pi over 6, or 30 degrees, depending on where you're at in your class, what level, equals to what? We said it's opposite over adjacent. So with respect to this triangle, our opposite side from pi over 6 is, like we said, 1/2, right? 1/2 over hypotenuse. Our hypotenuse is 1. So it's simply just 1/2. So, and then you can do that for cosine. So cosine of theta, which in this case is pi over 6, right, equals to, again, root 3 over 2, or 1/2, because we have x here, right? You could do that with 60 degrees. It's fundamentally easy or it's convenient because we have a radius of 1. So we don't have to really, and even so, we would divide into that, and it would reduce whatever. But when speaking in terms of the unit circle, it's nice and pretty that we have x and y always corresponding to a cosine and sine theta, respectively. Now, how does that work when it comes to graphing it? Well, when we talk about, say, the sine function, and we want to graph y equals to sine of, say, x, not theta, but x. We're using x, right? Y, and then x axis, right? Well, we're graphing sine theta as it changes around the unit circle. So in this case, and when talking about this graph here, we're not even thinking about cosine. So we're thinking about all the y values, right? So at sine of 0, right, we have cosine equals to 1, or x equals to 1, right? Its highest value. But at that same time, we have no development in any respective height for y. There's nothing really there's nothing really perturbing in y, so we have nothing. So there's no 0, right? And we can give it its 4 corresponding points. We can just go and say, well, x in this case corresponds to theta because that's going to be our independent variable. We're trying to graph what happens to y, or what happens to sine theta as we move with respect to theta. So let's just give it its convention, give it its conventional 4 points. So we can say 0, and then we'll use pi over 2. Right? And these are solely up to us, and you have infinitely many angles in between. We can add pi over 6, pi over 4, right? Pi over 3, then pi over 2, as you would see on the unit circle. But for convenience sake and just to make it easier on us, we do it in this manner. Just kind of 4 larger points that we can reference. So pi, was it 3 pi over 2, I think that is? I always forget. If I mess up, my bad. Okay, so we have some 4 points, right? And that we know that the maximal of sine and cosine, the maximum points it's ever going to reach is just 1 and -1, right? Why is that? Well, like we just said, at sine of 0 we have 0, right? But cosine is 1, and in that case, if we look along the y-axis, cosine is 0, right? But we have y equals to 1, or sine equals to 1 at this point, and that's the maximal point you're going to get because the radius is 1. So again, the convenience of having a radius of 1 is very nice and neat. So 1, -1, right? So at 0, sine of 0 is 0, because you see no development in any type of no increase in height or anything with y, right? Now, as we move along theta, we see that y starts to grow, and in this case it's 1/2, but we haven't clocked it for pi over 6. We want pi over 2. And then if we talk about 60 degrees, right? That's supposed to be a straight line, which is apparently and evidently not. Dang. God, you guys, I suck. All right, cool. Better, much better. I'm happy with that. All right. So now this is a 60-degree angle, right? So pi over 3. We didn't clock it. We haven't clocked it here yet. I mean, you can put in that point, but you'll see. At pi over 3, we know that these are inverted, right? Root 3 over 2. So we actually have our sine is root 3 over 2, or our y is root 3 over 2. And then finally, at pi over 2, we have sine equals to 1. And we can just go ahead and put that in, right? Now, if we continue moving theta, and then we see that at pi, y, or sine of theta, has now dropped back down to 0. Right? As you can see, cosine is -1, the larger point, but there's no development of y, right? There's no actual height in this length, right? In this side. So, and then we can continue using that, and as you can see, our sine theta gets negative here, negative, and it grows. So if I make a 30-degree angle, right? Oh, man. Whatever, that's good. I'm not gonna get picky. So 30-degree angles, right? And all of a sudden 60 degrees, right? As you can see, this side here, it's growing. And then let's just pretend that never happened. Right? So this side here, and then this side here is growing. And then finally, when we reach 3 pi over 2, or 270 degrees, we reached a maximum of 1 again, but we see that it's in y is negative. So -1, right? And then again, excuse me, y is still negative as you go into the 4th quadrant, but as theta continues moving in a positive direction, you see that sine of theta is decreasing, decreasing negative. So it's decreasing negative. Follow this back up, and then there you have a nice wave. Well, it's supposed to be a nice wave. Oh my god, I did hire someone to do this. Not that I can afford somebody. Get my nephew to do it. Bribe him with cookies. I can't get this sign. I can get this. I'm just gonna kind of wing it. Okay. Anyways, you guys get the point. Oh god, that's embarrassing, you guys. Jeez. FYI, work on these graphs when you're doing them. Teachers like it when they look nice and neat. I could never do it. My teachers hated my writing. It's easier for grading. I used to have instructors come up to me afterwards and used to have to like kind of verify whatever they were looking at. Okay, so that's a sine of theta. That's a graph, right? And it continues and it continues as you go about the unit circle with more revolutions, and it continues, and you continue going on that. Now, what about negative? Negative, right? So this was theta going in the positive terminal or positive direction, which means it's counterclockwise, right? Counterclockwise is positive, but if we go clockwise, it's a negative degree, right? So everything is negative, and it works the same. So you know that negative pi over 2, which is this guy right here, if we're going in the clockwise direction, it's negative pi over 2, no longer 3 pi over 2, but negative pi over 2, right? Negative pi over 2, right? And then this is what? It's pi, or negative pi, right? And then you have negative 3 pi over 2, and then negative 2 pi. This goes on forever. Okay, so it's the same thing. As we said, sine is increasing, right? Negative. Until you get to negative 3 pi, negative pi over 2. So it's increasing negative, so we have it increases, and now finally reaches a point of negative 1. Reaches a point of negative 1. And then, so as you can see, the lengths for right here again are decreasing. So sine is decreasing negative, right? And then finally reaches 0 at negative pi. Again, sine is increasing positive, right? As you can see, these angles are starting. Just look at them; they're starting to grow. Oops. They're starting to grow, and then you have them growing, right? And you're looking these guys right here, and 60 degrees. Then all of a sudden you get to negative 3 pi over 2. You have a positive 1, and then decreasing positive back down to 2 pi. So you can clock that. God help us all. I'm gonna try this. Okay. What I'm gonna do is show you this. If you guys don't know what the sine graph looks like, let's see what sine of x. There we go. That's nice and neat. That's exactly what I was trying to do. That's your goal right there. All right, and then it just goes negative. So keep that in mind. And the same goes with cosine of theta. You realize where it stands. Again, at 0, cosine is 1, right? It's at its highest degree, and then all of a sudden you see these lengths for cosine decreasing as theta continues positive, and same for negative as theta continues negative. So you can actually represent those using a cosine graph. And remember, they're two different graphs. You're looking from two different perspectives, and then you can get into tangent, secant, cosecant, and that's a whole nother dimension of problems I'll get into later, but I just wanted to highlight simply this right here. All right, so let me know if I've embarrassed myself enough, or let me know if you guys have any concerns, questions, comments, please. I love the feedback, even if it's suggestive criticism. And thank you guys for always responding. I love it. All right, you guys, take care.